Shoot!
That was a really cool reaction. But I can't help but wonder, what was the product that was produced? Like, what was the name of it? I know I saw gas come from that reaction, but how would I name it?
Well, we could use chemical nomenclature. The rules followed to name a chemical.
Oh yeah, chemical nomenclature. We can use that to figure out if a molecular compound is ionic, covalent, or an acid. Also can determine the charge for us. Oh, that's really helpful.
There are three types of chemical compounds. The first we'll be talking about is binary ionic compounds.
A binary ionic compound is a compound that is made up of two or more elements, one nonmetal and one metal.
For the formula, first you find the charge of the anion, then you write the cation, the metal, and then the anion, the nonmetal. Lastly, you select the subscripts that make the total positive and negative charges equal.
We can do this by using a crisscross method. This is where we take two or more elements, take their charges, and crisscross them. This will give us the amount of elements per chemical compound. Naming a binary ionic compound. The first step is to write down the metal. Some metals can have more than one type of ion. This means that it has more than one type of charge. To indicate this, we can use Roman numerals after the metal that is written in parentheses. After we write the metal, we'll write the nonmetal down. And this is simple. We just put the actual element down and add I to the end.
Now we will be talking about the other type of ionic compounds, polyatomic ionic compounds.
A polyatomic ionic compound consists of one metal or nonmetal bonded to a polyatomic ion.
For the formula, first you find the charge of the ion by using the polyatomic ion sheet. Next, the nonmetal or metal will be first in the formula. The polyatomic ion goes second. If there is more than one polyatomic ion, then use parentheses. As stated previously, you will use the crisscross method to find the correct charges. For the polyatomic ion, you will need to use the polyatomic ion sheet to find its charge.
Now we name the polyatomic ion. First, we write the cation or anion, and then follow it by the Roman numeral if the metal has more than one type of charge. Write the polyatomic ion as it is on the sheet after the metal or nonmetal. If the polyatomic ion is bonded to a nonmetal, then you only write the nonmetal as it is. Our first ionic compound, we have Mg plus N. Mg, or magnesium, is our metal, and nitrogen is our nonmetal. The first step we'll need to do is find their charges. If we look at Mg, we can see that it has a +2 charge because it is in the second group. Looking at nitrogen, it has a -3 charge. Now we will do the crisscross method. To do this, we simply cross the charges of the two elements and write them as the coefficients for the amount of element per compound. This will give us magnesium 3 nitrogen 2, or Mg3N2. Now that we have our formula, we can name our binary ionic compound. Because our metal, magnesium, only has one type of ion charge, we simply just write magnesium with no Roman numeral prefix. After we write magnesium, we'll follow it with our nonmetal, nitrogen. This part is easy. Just add an I to the end and make it nitride. This gives us magnesium nitride. For our polyatomic ionic compound, to make the formula for our two elements we have, manganese and phosphate, we will need to do the crisscross method again and find their charges. Manganese has more than two types of charge, but in this case, it'll have a +2 charge. Our polyatomic ion, phosphate, by looking at the polyatomic ion sheet, has a -3 charge. We repeat the steps for the binary ionic compound by crossing the two charges. This will give us our chemical formula for our compound. crisscross method, we will be given manganese 3 and phosphate 2. We'll need to make sure phosphate is inside the parentheses so that we can tell the difference of the amount of elements per polyatomic ion and the number of polyatomic ions, which is symboled by the 2. Our formula for our polyatomic ionic compound, we'll need to write the name. Because our polyatomic ion compound has a metal with 2 or more charges, in this case a +2 charge, we'll need to signify this by using parentheses and a Roman numeral of 2 after we write the manganese. After this, we simply just write the polyatomic ion, phosphate.
We will be talking about the second type of chemical compounds, covalent compounds.
A covalent compound is a compound that has 2 or more nonmetals bonded together.
For the formula, first you translate the names of the elements into symbols using the periodic table. Then you translate the number of molecules, the numerical prefixes, into numbers.
To name a covalent compound, all we have to do is leave the nonmetals as they are. Then, the last nonmetal in the formula gets an "ide" ending to it. Numerical prefixes, as seen in the top right corner here, are used to describe the amount of each nonmetal in the molecule. If the first nonmetal consists of only one element, then the mono prefix is not needed. The element that goes first in the chemical name is the element that has the least electronegativity. The covalent compound we have today is pH3. These both are consisted of nonmetals. To figure out which one we would write first in our formula, we would look at the electronegativity of them on the back of our periodic table. After we find the electronegativity and can figure out which one we are going to be writing first, which in this case is phosphorus, we need to figure out what prefix we are going to use for them. Covalent compounds, if you remember from what we said earlier, need prefixes to determine the amount of elements in each compound. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. An easy way to remember this, or an analogy, is my dog tried to put his hands on Natalie's desk. Just repeat that a few times and hopefully you will be able to remember the prefixes. Phosphorus only has one element or one atom in this formula, so it would be written with mono, but because it comes first, we do not need to put the mono. So in this case, we will just write phosphorus. After phosphorus, we write the next nonmetal, which in this case is hydrogen, and it has 3 elements or atoms in the compound. If we look back to our prefixes, 3 is tri, so we will write trihydrogen. But before we finish that, don't forget we need to add an "ide" to the ending of the second nonmetal. This should look like phosphorus trihydride. We want to go from the chemical name of the covalent compound back to a formula. All we would need to do is look at the prefixes and make sure by looking at the electronegativity that the right nonmetal is first. Another example, we have N2O3. The N is nitrogen and the O is oxygen. If we look at the number of atoms in this compound for nitrogen and oxygen, we can see there are 2 for nitrogen and 3 for oxygen based on our formula. If we look back at our prefixes, all we need to do is write dinitrogen trioxide. Don't forget to add the "ide" at the ending, and make sure you have the correct prefix before writing it down. If we were to take the chemical name and go back to the formula, make sure you look at those prefixes and then write what that prefix stands for by number. In this example, di being 2 and tri being 3. and write them as coefficients in front and smaller and below on your nitrogen and oxygen, making N2O3 again.
The third type of compounds we'll be discussing are acid compounds.
An acid compound consists of one or more hydrogen atoms bonded to at least one nonmetal or one polyatomic atom.
For the formula, you will just solve like an ionic compound using the crisscross method as stated earlier.
There are two types of acids, binary and polyatomic. To name a binary acid, we first write the word hydro, and then the nonmetal that it's bonded to. And the nonmetal will have an "ic" at the end of it. After the nonmetal is written, we write the acid. For a polyatomic acid, the name of the polyatomic ion will be written down with either an "ic" or an "is" ending. This ending is determined by whether the polyatomic ion ends in an 8, which will be translated to "ic," or ends in the word "ite," which is translated to "us." The first acid compound we are going to be doing is a binary acid compound, HCl. HCl only has one element or atom of hydrogen and one atom of chlorine. To name this, we'll need to write the prefix hydro for the hydrogen atom. After hydro, while keeping it still the same word, we'll need to write chlorine, but change the ending of chlorine to an "ic," so it would sound like chloric. When putting these two together, it should be hydrochloric. Don't forget to add acid after the hydrogen and the nonmetal. This should end up sounding like hydrochloric acid. We have a polyatomic acid. This polyatomic acid is HNO2. The polyatomic ion in this formula is nitrite. To name this, we won't need to write any hydro or type of hydrogen prefix or word down because of the polyatomic ion. Instead, all we need to do is write the polyatomic ion, in this case, nitrite. But because it has an "ite" ending, like we said before, it'll need to be changed to an "us" ending. When writing this down, it should look like nitrous. After nitrous, make sure to write acid again to specify that the hydrogen is there and that it is an acid.